Today we will discuss the model 2 in graphical method. So the previous class I have explained objective function is maximization, constraints are less than equal type. Now today we will discuss objective function is minimization, constraints are greater than equal type. Then how to solve that particular problem. So the same 6 steps will be there. Already you know graphical method, 6 steps will be there. The same steps we will apply for this problem also. Okay. So write on the problem, solve the following LPP by using graphical method. So objective function is given minimum z. So minimum z equal to 600x1 plus 400x2. 600x1 plus 400x2. So this is the objective function. Now see this one, this is minimization. So previous problem we have done is maximization. Okay. So subject to the constraints, right on next line, subject to the constraints. First constraint 15x1 plus 15x2 greater than or equal to 200. Now the second constraint 30x1 plus 10x2 greater than or equal to 400. Third constraint 20x1 plus 50x2 greater than or equal to 440. Okay. Now how many constraints are there? 3. Previous problem. Constraints may be 3, more than 2, 3, 4, 5, more than 2 means that may be 3, 4, 5, no problem. Only decision variables are 2, x1, x2. You see all these constraints, how many decision variables are there? Only 2 decision variables are there, x1 and x2. So that and x1, x2 greater than 0. So now this is the second problem. Okay. So objective function is minimization. Constraints are greater than or equal to type, and decision variables are not. So this particular problem can be solved by using graphical method or not. You have to check. So if you want to apply graphical method, what are the 2 points that should satisfy? Only 2 decision variables are there in the problem, then you can solve by using graphical method. How many decision variables are there? X1, x2. That means only 2 decision variables are there. That means this particular problem, first LP, can be solved by using graphical method. No equality type constraints are there in the problem, so you can solve. Okay. So how many steps are there in the graphical method? Already I have told. What is the step number 1? 6 steps are there. What is step number 1? Convert all the inequalities into equalities. These inequality constraints should be considered as equality type constraint. Okay, so shall we start solution? Yeah. Solution. Step number 1. Right. Convert. Step number 1. Convert all the inequality constraints. Convert all the inequality constraints into equality constraints. Convert all the inequality constraints into equality constraints. Then we get so all the inequalities, these are the inequalities, this should be converted as equalities. So just I will write equalities. This is equation number 1, this is equation number 2, this is equation number 3. So step number 1 is completed. So I have converted all the inequalities into equalities. So how many equations I got? 3 constraints, I got 3 equations. If you have 4 constraints, you will get 4 equations. Okay. So previous problem we have discussed only 2 constraints are there, so you are getting only 2 equations. So step number 1 is complete. Step number 1 is nothing but what is it? Convert all the inequality type constraints into equality type constraints. So step number 1 is completed. Next step number 2. What is step number 2? Already know. What is step number 2? Step number 2 is nothing but plot these equations on the graph. These equations should be plotted on the graph. If you want to plot these equations, you require points. And the step number 2 is nothing but first you have to identify the points. How many equations are there? 3. That means you require 3 points and then plot the points on the graph. That geometrically represent a straight line. Then you will get a geometrical representation of a straight line. Okay. So how will you identify the points? I have already told the same thing you have to adapt here. Okay. So right, step number plot, here go to plot each equation on the graph the graph, as each one will geometrically represent a straight line. Geometrically represent a straight line. Geometrically represent a straight line. For that you require the points. Okay. So how will you identify the points? One by one I will consider. Okay. Consider equation one. Right. Step number. Consider equation one. Equation one first I will consider. Equation one. Put x1 equal to 0. Put x1 equal to 0. So in equation one, this is equation one. Put x1 equal to 0. Put x1 equal to 0 means then what you will get? 15x2 equal to 200. 15x2 equal to 200. That means what is x2 value? x2 equal to 200 by 50. So you have a calculator is allowed. If you want, you can use a calculator. Okay. So this means what is that? How many times it is there? If you have 15 ones are 15. 50. 15 threes are 100. 13 point 200 by 50. If you have calculated, you can calculate. Calculate that value. That value gives what is it? 200 divided by 50. That gives 13.3. You will get all of you will get 13.3. Okay. So next, same equation. Only you are considered put x2 equal to 0. x2 value is equal to 0. The same equation x2 equal to 0. Okay. So x2 equal to 0 is what you will get? 15x1 equal to 200. Same equation. So that means what is x1 value? x1 equal to 200 by 15. That means 13.3. 1 plus is enough. So 13.3. So that means what is the first point you are getting? First point you are getting is x1 comma x2. So x1 value is 13.3. x2 value is 13. x2 value is 13. That means you are getting the first point. So first equation point is 13.3 comma 13.3. Now similarly you can calculate the remaining equations. Okay. So I will write next one. What is the consider equation 2. Consider equation 2. Put x1 equal to 0. Put x1 equal to 0. This is equation number. Now equation 1 is completed. So equation 2 is this one. Okay. So put x1 equal to 0. This one x1 equal to 0. Then what we get? 10x2 equal to 400. 10x2 equal to 400. That is what is x2 value? x2 equal to 40. x2 equal to 40. Okay. x2 equal to 40. Same equation. What you have to do now? Put x2 equal to 0. x2 equal to 0. If x2 value is equal to 0, that means what will get? x2 is equal to 0. That means 30x1 is equal to 400. 30x1 is equal to 400. That means from this equation you can calculate x1. So x1 equal to 400 divided by 30. 400 divided by 30. So I think all of you have calculators. So you can use the calculator and you can calculate that value. 400 divided by 30. 400 divided by 30. Again you are getting 13.33. I think 13.3. 13.3. That's the same value. I think 13.3. Next, put x2 equal to 0. Same equation. You have to put x2 equal to 0. So x2 0 means what is the equation? What is the equation? x2 0 means what you will get? 30. X1 0 means what you will get? 10x2 equal to 400. 10x2 equal to so you have finished this one. I think you have finished this one. So x1 x2 value I want. This is the x1 value. This is the x2 value I want. So what is the point you are getting? You are getting the point x1 value 13.3 from x2 value 40. So second point I got. First point 13.3, 13.2. Second point 13.3, and then 40. x1 comma x2. x1 comma x2. x1 is this one. x2 is that. Okay. So now point number 2. Second point is completed. One more equation is there. Third equation. Again you have to consider that. Okay. Consider equation number 3. Now consider equation number 3. consider equation 3. Equation 3 is this is equation 3. Put x1 equal to 0. x1 equal to 0. x1 0 means what we get 50, x2 equal to 440. 50, x2 equal to 440. That means x2 value you have to calculate. So x2 equal to 440 divided by 50. 440 divided by 50. So you can use the calculator. 440 divided by 50. So you will get 8.8. You will get 8.8. Same put x2 equal to 0. x2 equal to 0 implies x2 0 means what you get 20. x1 equal to 440. That means what is the x1 value? x1 equal to 440 divided by 20. 440 divided by 20 means what we get? This is nothing but 22. 22 you will get. So now I got third point. What is the third point you have? Third point is x1 comma x1. 22 comma 8.8. 22 comma 8.8. So I think how many equations you have? So you have three equations. I got 3 points. 13.3 comma 13.3 is the first point. Second point is, what is the second point you got? 13.3 comma 40 is the second point. And third point is 22 comma 8.8. So now I got all the 3 points. 3 equations, 3 points I got. Now I can draw the graph. Okay. So then step number 2 will be finished. So draw the graph. So how to draw the graph? So see x1 values. What is the x1 value? Highest value. This is x1. x1 highest value is 22. In x2, what is the highest value? Highest value 40. So scale should be up to 40 both sides. Both sides you can take 40. So 5 you can take 6. Scale is your wish. You can consider anything. So I will draw the scale now. I will draw the graph. So this is x1. All of you are showing x1. This is x2. This is x2. Generally x1 you will take, but this is x1 and x2. x1 and x2. So this is origin. Origin point is O. This point is origin. Now you can consider scale. 40 is the highest value. So 5 difference means what is it? 10. 40 means 8 values I will consider. So I will consider 5, 10, 15, 20, 25, 30, 35, 40. x1 40 I am considering. The same thing I am considering here also. 5, 10, 15, 20, 25, 30, 35, 40. So 40 I am considering. Okay. So first value. What is the first value? 13.3 comma 13 point. Roughly you can identify. Because the practical examination graph will be provided. Their examination you have to draw the graph. You know the script only. So that means roughly you can identify that point. So this is a big point. So what is the big point? Big point is this is 10 plus 25. 12.5 is the big one. 13.3 is even more. So I am considering 13.3 is this value. 13.3 like this. 13 point roughly you can identify. And x2 value is also 13 point. Roughly you can identify 13 point. So 13.3. Use the scale and join these points. This is equation number 1, line 1. Equation number 1. This is line 1. Okay, I think all of you are able to see this. This is line 1. Okay. Now first line is completed. Next second line. 13.3, 40. x2 x1 value 13.3 at the same point. Same point will be there. 13.3. x2 value is 40. 40 means this one. 40. So now drawing these points by using the scale. Use the scale. I am not using the scale, but you have to use the scale because whenever the constants are more, you have to use the scale. Otherwise, 3 points coordination we get. Okay. So now second line is completed. Now the third one. What is the third one? Third one is 22 comma 8.8. So 22. Identify 22. x1 value 22. Roughly you can identify this is 22. Roughly you can identify 22. And then 8.8. 8.8 means roughly this is 7.5. 8.8 means roughly you can identify 8.8. Okay. Roughly you can identify 8.8. And join these points. This is line 3. Now second step is completed. Step number 2 is what is it? Step number 2, plot each equation on the graph. I have plotted all the equations on the graph as each one will geometrically represent straight line. If If you use the scale, you will get a straight line. Otherwise, you will get like this one. Okay. So use the scale, you will get a straight line. So all are straight lines. Okay. So step number 2 is completed. The most important step in graphical method is step number 3. What is step number 3? Identify the common region or feasible region. That is the most important. Okay. Now, how to identify the feasible region? I have told. If the constraint is less than equal type, below the line. Suppose this is the line. If the constraint is less than equal type, below the line is shaded. If the constraint is greater than equal type, above the line is shaded. Okay. Now in this particular problem, if you observe, this is the second model I have told. So in this particular problem, all are greater than equal type constraints. Only greater than equal to means what is that? Above the line. Above the line, only in the first quadrant is shaded. Why you have to shade only in the first quadrant? These are how many coordinates are there? 4 coordinates are there. Why you have to shade only first quadrant? Because in the problem x1 x2 greater than or equal to 0, and those are positive values. Where you will get positive, both values are positive. This is plus plus, both the values are positive here. Remaining this is plus minus, minus plus, and then minus 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 and minus plus, like that. Okay, so that means what is that? Only in first quadrant you will get both the values are positives. That means you have to identify the feasible region only in the first quadrant. Remember this point. Only in first quadrant, this is the first quadrant part. Only you have to identify feasible region in this part only. Okay. Now see the first constraint. First constraint is less than equal type or greater than equal type. First constraint is greater than equal. Greater than equal means above the line is shaded. Now see, this is the first line. I am showing the first line here. This is the first line. This is the first line. Above the line. Above this is below. This part is below. This part is above. So above the line. Just I will indicate because I have to identify only common region. Okay. So how many parts are there? This is the first line. Upper. Okay. So only 2 shades are there. So I have upper and like this. The region. Okay. Next, second line. Now see the second line. This is the second equation. This is the second equation. Second line is also greater than equal to. Greater than equal to means above the line. This is below. This is above. Okay. Above the line is shaded. Above the line is arrow mark is like this. How many parts are there here? This part and this. Like this. Like this. Okay. But I remember only common part you have to identify. Common part only you will identify. That's why I am putting just arrow marks. Okay. Third constraint. What is the third constraint? This is the third line. Third line is also greater than equal to. Greater than equal to means this is above. Third line is this one, above to this one, below to this one. Okay, so above the line is shaded. Just I am giving arrow marks. If you have color pencil, you can try it out. Then you will identify different colors. Okay, so then you have to identify the common part. What is the common part for all the lines? Okay, so whenever all the constraints are less than equal type, remember, whenever all the constraints are greater than equal type, sorry. Whenever all the constraints are greater than equal type, always identification of feasible region is very easy. So how will you, what is the common part you will get? What are the common edges, outside edges, that is the common region. Outside edges, because all the lines like this, it will come like this. That means what is the common part for all the lines, whatever may be the outer parts of this region, that is called common region. Outer parts, you see this one, outer edges. So this point is an outer edge. This point is an outer edge. And this is not an outer edge. This point is an outer edge. So that means what are the points you get? This is we are getting A, and this is B, and this is C. And this is called the common part. Only outer edges, wherever you have outer edges, that is the common part. This whole entire thing is about common part. This is not a common part because second line starts from here onwards. So it is not a common part. It is not a common part. It is also not a common part. No line is here, so it is not a common part. So here, this part, this is also not a common part because third line starts from here onwards. Third line starts from here onwards. So this is not a common part. This is also not a common part. This is also not a common part because third line again starts from here. So all are ruled out. All are ruled out. Only outer edges will be common part. So if you consider this region, first line will be there, second line will be there, third line will be there. If you consider this point, first line will be there, second line will be there, third line will be there. So what is the common part or feasible region for this particular problem? What is the common part? A, B, C is the feasible region. A, B, C is the feasible region. And whenever constraints are only greater than equal type, region is far from the origin. This is origin. Whenever all the constraints are greater than equal type, region will be far from the origin. Whenever all the constraints are less than equal type, it will be closer to your origin. And the previous problem, all the constraints are less than equal type. That's why you got feasible region closer to this origin. So if in this case all are greater than equal type, so that's why the feasible region is far from the origin. And the O will not be included. Whenever all the constraints are greater than equal type. Whenever all the constraints are less than equal type, O will be included because it is closer to your feasible region. So in this particular problem, what is the common part? What is the feasible region? A, B, C is the feasible region, right? Step number 3. I think you have drawn the graph. You have drawn this graph like this. You can identify the common region. These outranges are called common region. Outranges I have identified. This is A and this is B. This common part is called B and this part is C. This upper part is the feasible region. Okay. So step number 3. Step number 3. Write down all of it. Step number 3. A, B, C is the feasible region. A, B, C is the feasible region. So the main step is complete. Remaining steps are very easy. What is step number 4? You have to identify the corner points of the feasible region. And you have to identify A point, B point, and C point. You have to identify. That is step number 4. Right. Step number 4. Step number 4. Identify. Step number 4. Identify. Step number 4. Identify the common part. Sorry. Identify the coordinates. Identify the coordinates of the feasible region. 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 Step number 4. First point. What is the first point? A. Where is the A point? A point is this one. This is nothing but x-axis. X-axis point already I have told. What is x-axis point? A comma 0. X-axis point is A comma 0. A comma 0 means what is the A value? What is this value? This value is 13 points. This value is 22. This value is 22. Okay, so 22 is the value. So 22 comma 0. A point is 22 comma 0. Next, you have to identify the B point. B is important. B is this is intersection. Intersection of which lines? What is this line? This line is equation 3. And what is this line? This line is equation 2. So B is the intersection of 2 and 3. And if you solve second equation or third equation, you will get the B point. Right? B is the intersection of 2 and 3. Equations 2 and equation 3. Equation 2 and equation 3. Already equation 2, equation 3 is with you. Step number 1 you have already. Equation 2 and equation 3. What is equation number 2? 30x1 plus 10x2 is equal to 400. This is equation number 2. And equation 3. What is equation 3? 20x1 plus 50x2 is equal to 440. Okay. So make it either a x1 coefficient equal or x2 coefficient equal. Then only you can solve these equations. Okay. So meanwhile, I will assume as for only for solving purpose, I will assume as this is 1 and this is 2. Only for solving purpose. Main equations are 1 to 3, that is different. Now for solving these 2, otherwise if you have calculated, you can write 2 and 3 only. This is 2 and 3, you are solving. Okay. Second equation and third equation. So make it as equal. Either x1 coefficients or x2 coefficient should be equal. Now see here 30 is there, here 20 is there. You can multiply with this one. Otherwise simply what I will do, I will make it as x2 coefficient equal. Because already 10 is here. Just if you want to multiply with 5, then automatically we get 50 here. So that means what is that? 2 into 5 and 3 into 1 only. 3 into 1. Otherwise you can make it as x1 coefficient equal. That is your wish. Okay. So that means I multiply with 5, 150 x1 plus 50 x2 is equivalent to 2000. Is equivalent to 2000. Okay. And then this 1 into means same equation. 20 x1 plus 50 x2 is equivalent to 440. Is equivalent to 440. Okay. Now you can solve these equations by doing minus subtraction. By doing subtraction, automatically you will get 50 x2 minus 50 x1. X2 will be eliminated. X1, this is 150, 20, that is 130. 130 x1 equal to, actually this is 1550. 2000 minus 440, this is 1550. 1550. So now you can calculate x1. So x1 equal to 1550 divided by 130. 1550 divided by 130. You can use the calculator. 1550 divided by 130. So 11.9 I am getting. So you can check 11.9. 11.9. I am getting 11.9 is the value. If you want want, you can check it and cross check once. Okay, and then substitute this x1 value in equation 2 or equation 3. The equation 2 or equation 3, if you substitute, you will get the remaining value. So I am substituting x1 in equation 2. Okay, right. Next step, from 2, stay here I am writing from 2 means from equation 2. This is equation number 2. I am putting x1 value 11.9. So this is nothing but 30 into from 2 implies from 2 implies from 2 what we get 30 into 11.9 plus 10x2 is equivalent to 400. 10x2 is equal to 400. You have to calculate x2. So that means this implies 10x2 equal to 400 minus calculate that value, multiply that value 11.9 into 30 11.9 into 30. That means you are getting 357. I'm getting 357. This is plus 357. Becomes minus 357. 357. That means what is the value you are getting? Just I'm writing here. That means what you get? This implies x2 equal to what is the value? 400 minus this one means this is 43 you are getting. 43 I am getting. So 43. So x2 equal to 43 divided by 10. That means what is the x2 value you are getting? 4. Now I have solved the b point. What is the b point I am getting? Now I am getting the b point. So what is the b point I got? B point is nothing but x1 value. What is the x1 value? 11.9. What is the x2 value? 4. Now I got the b point. So a point is 22, 0. A point I am getting 22.0. B point is 11.9, 4.3. Last point. What is the last point? C. C means what is it? This one is C. C at the y-axis point. What is the y-axis point? 0, a. Let us 0, b, whatever it is. 0, a. Okay, 0, a. That means what is the C point? C point equal to 0, what is this point? This point is 40. This point is 40. Now I know all the points. What is the A point I got? Just I am writing the A point here. A point is 22, 0. A point is 22, 0. B point 11.9, 4.3. And C point is 0, 4. That means step number 4 is completed. Step number 4 is completed. Now I have to solve step number 5. Step number 5 is nothing but check your objective function. What is the objective function given? So step number 5, see the objective function is given maximization or minimization, right? Step number 5. Step number 5, given that objective function is given, minimization to it. So right, minimum z equal to what is the value given? 600x1 plus 400x2 Now, how many corner points you have? 3 corner points. The 3 corner points should be substituted, and after that you have to identify the minimum value or maximum value. Minimization means you have to identify the minimum value. So first I will calculate ZA point. A point is 22, 0. So 22, 0 means what is that? 600 into 22. 600 into 22 plus 400 into 0. 400 into 0. Okay, you can simplify, you will get the value here. So use the calculator and calculate the value given by next ZB point. What is B point? 11.9, 4.3. That means 600 into 11.3 plus 400 into 11.9. 400 into 4.3. You can calculate by using the calculator. You will get the value here. Okay. And last point. What is the last point? ZC. C point is 0, 40. That means 600 into 0 plus 400 into 40. 400 into 40 means this is 16,000 units. 16,000 is answer. And remaining values. So calculator is allowed. You can calculate the values. Okay. Just I am calculating 22 into 600. 22 into 600. So this is 13,200 you will get. 13,200. 13,200. Okay, and then this value I will calculate, and I will tell you, just give a minute. That is 600 into 11.9. 11.9. That value, this value is you will get this value. Just I am writing the value. That value will get 7140. 7140, and calculate this value. This value is 400 into 4.3. 400 into 4.3. 1720. This value is 1720. Okay. So 1720 plus 1720 plus what is the value you are getting? 1720 plus 7140 plus 7140. 8,860. 8,860. 8,860. Just I am running the values. So I got 8,860 is the value I get. 8,860. This is 600 into 11.9 plus 400 into 4.3, 8,860. Now, objective function is minimization or maximization? Minimization. Go for minimum value. This is 30,200, 8,860, 16,000. Which is minimum? Minimum is 8,860. Okay, for this particular problem, answer is minimum value of z equal to 8,860 at the point B. What is the B point? 11.9, 4.3. At last step, step number 6. Step number 6. Step number 6. The optimum solution. Right, the optimum solution to the given LPP. The optimum solution to the given LPP by using graphical method. By using graphical method is minimum z equal to 8,860 at the point. What is the point you got? B point. What is the B point? 11.9, 4.3. This is a manual calculation. If anything is wrong, you can correct it out and you can do the problem. Same as it is. Textbook is given 12.4, but I am getting this calculation. Just verify the calculation part. If anything is going wrong, just you can correct it and you can do the same procedure. So for me, I am getting 8,860 at this point, 11.9, 4.3. Okay. So the same 6 steps I have used. What is the first step? Convert the inequalities to equalities. And what is the second step? Plot those equations on the graph as each one will geometrically represent a straight. Step number 3 is what? If the constraints are less than equal type, below the region is shaded. If the constraints are greater than equal type, above the region is shaded. So in this case, all the constraints are greater than equal type. That's why I have shaded above the region and I have identified the common part. So common part I am getting outer edges. Outer edges means ABC is the common part I am getting in this problem. So next step is I have identified the A point, B point, and C point. I have identified, and after that I have considered the objective function that is given the minimum set. Then I have substituted A point, B point, and C point. Objective function is given minimization, so I have go for minimum value. So what is the minimum value? I got 8,860. At which point? B point. So this is your answer for this particular problem. So this is the model. Whatever may be the problem, the procedure is same for all the problems. Just little bit difference. Maximization means you are going for maximum value. Minimization means you are going for minimum value. Less than equal type means below the region is shaded. Greater than equal means above the region is shaded. So in the previous class I have told objective function maximization constraints are less than equal type. Now this problem is objective function is minimization constraints are greater than equal type. Next model, third model we have. What is the third model? Mix. Objective function may be anything, either maximization or minimization. If it is maximization, go for maximum value. If it is minimization, go for minimum value. And constraints will be mix. Mix means both will be there. Previous problem only less than equal type. This problem only greater than equal type. Now third model we will discuss both. Both are included, less than equal as well as greater than equal. Procedure is same. Those 6 steps only we will use. Okay, less than equal means below the line is shaded. Greater than equal type means above the line is shaded. And you have to identify the common part. If common part exists, then you will go to the next. That means step number 4 and 5, and you will solve this problem. So tomorrow in the next class I will explain the third model. Third model means objective function is either maximization or minimization. Constraints are both mixed, less than equal to or greater than equal. But graphical method, those 6 steps will be there.